This is Unit 5, Right Triangles, Lesson 5.5, Angle of Elevation and Depression. Please make note of both the location that you are watching this video as well as the date and time, and don't forget a parent, guardian, or teacher sign-off. We're going to follow your brain is in your hand technique. We're going to finger track read, highlight, underline, draw a label list, and then follow have, need, do. So let's finger track and read first this particular problem. It says in triangle STU, T is a right angle. The measure of angle U is 53 degrees. The side adjacent to U is 10 meters in length, not the hypotenuse. Find the length of SU. So we finger tracked and read. Now we're going to highlight and underline, draw a label list. We have a triangle STU where T is the right angle. So we're going to draw it like this. There's T, T's the right angle. There's S, T, and U. We're going to cross it out as we go. The measure of angle U is, that's an equal sign, 53 degrees. So that's 53 degrees. Cross it out. The side adjacent to angle U, but not the hypo, is 10 meters. Adjacent, that's going to be here, 10 meters. Find the length of S to U. S to U is right there. That's our unknown. Now, we label HOA. Label HOA. This is our hypo. Our opposite, if this is 53, our opposite is here, and our adjacent is here. So we have the adjacent side. We want SU, which is the hypo. We have an AH combination. Now you come over here and you look for an AH combination. You see that it's cosine. So we write that ratio out. Cosine of theta over 1 equals adjacent over hypo. Where did I get that from? Right there. Take a moment and copy that down. So now let's circle, plug, chug. Cosine of theta, so we're going to write cosine 53 degrees, put parentheses around that, over 1 equals adjacent, which is 10 meters, over our hypo. We don't know it, so we'll call it x. Write that down. Now we're going to cross multiply. So we have cosine 53 degrees times x equals 1 times 10. We want x by itself. So I'm going to divide both sides by cosine 53. Keep parentheses around that. So x is going to equal 10 divided by the cosine of 53 degrees, which is going to be 10 divided by, let's find the cosine of 53. 53 cosine, that's 0.6018, 0.6018. So I'm going to go 10 divided by that. So 10 divided by 0.6018, and I get 16.6. So our hypo here is going to be 16.6. Okay, the next lesson is still about SOHCAHTOA, except we're going to add 2 key vocabulary words. 2 key vocabulary words. And these vocabulary words are angle of elevation and angle of depression. An angle of elevation starts at a horizontal line and goes upward. So trace with me this horizontal line. Now draw a little arrow upward and create an angle. That is an angle of elevation. Starts at a horizontal line and angles upward. That's called an angle of elevation. Angle of depression starts at a horizontal line and goes downward. So start at the horizontal line. Now draw an arrow and go down. That would be an angle of depression. Starts at a horizontal and angles downward. Angle of elevation and depression. Notice both of these start, very important, at a horizontal. So an angle of depression, angle of elevation. Depression starts, let's make this nice and big so we can see this. Angle of depression starts at a horizontal and angles downward. Starts at a horizontal, angles downward. Angle of elevation starts at a horizontal and angles upward. Okay, it says in the following diagram there is only one angle of elevation and one angle of depression. Sweep and label the angle of elevation and depression. Angle of elevation starts at a horizontal and sweeps upward. So we start at a horizontal and sweep up. Our X here is the angle of elevation. That's angle of elevation. Angle of depression starts at a horizontal and sweeps downward. So horizontal would be here and downward. That would be your angle of depression. You try. In the following diagrams, there's one angle of elevation and one angle of depression. Sweep and label the angle of elevation and depression. In both those diagrams, sweep and label. Use E for elevation and D for depression. Go. Okay, let's bring this really close. In this diagram on the left, your angle of elevation is right here in red, and your angle of depression is right here in purple. In this diagram, your angle of elevation is there in red, and your angle of depression is the 35 degrees in purple. There's no other angles that fit those descriptors. Knowing this, we're going to do a couple word problems together, using angle of depression and elevation. And we're going to follow the brain is in our hands. So first we're going to finger track read, highlight, underline, draw, label, list, have, need, do. So finger track and read with me. An airplane is flying at 5,000 meters altitude. The plane's angle of descent or depression to the landing strip is 7 degrees. Find the diagonal air distance the plane must travel to land using this angle of descent. So we're going to highlight or underline these key words. It is 5,000 meters in altitude. The angle of descent is 7 degrees. We want to find the diagonal air distance. Now we've finger tracked and read, we've highlighted and underlined. Now we're going to draw, label, list. So we have an airplane. Airplane's flying. It's my version of an airplane. At 5,000 meters. And its altitude. Altitude is always straight down and creates a right angle, just like you would in an altitude in a triangle. So that straight down is 5,000 meters. Make sure you get your units on there. Draw, label, list. The plane's angle of descent or depression, now this is tricky, is 7 degrees. Remember, angle of depression is a horizontal, so we draw a horizontal line angling downward, like so. That is our angle of depression, is 7 degrees. We want to find the diagonal air distance from the plane to the beginning of the landing strip. Let's say the landing strip starts right here. That is our x. So if you look carefully, technically we have two triangles here which mirror each other. Because if I connect this here, this is 5,000 on this side. I have a right angle here. Or I can go like this. Because of those two right angles, that forces these to be parallel, which gives this armpit to the z, and I can bring my 7 degrees down here as well. So I have two exactly mirrored triangle images. I'm going to use this one up here. Now I label my opposite, adjacent, and hypo. If this is the angle we're working with, the 5,000 is going to be the opposite. This is the adjacent, and then this is our hypo. Have, need, do. I have, need, do. I have the opposite. I need the hypo. I have an OH combination, so what do? I'm going to use sine. So it's sine theta over 1 equals our opposite over hypo. And bring this nice and close so it's easy to see. So I have sine of 7 degrees, parentheses, over 1 equals my opposite, which I don't know. Excuse me, opposite I do know. Opposite we do know. Our opposite is 5,000 in this case, 5,000 meters. And the hypo is x. Now we cross multiply. I have sine 7. Remember, that's not 7, it's sine 7 times x equals 5,000. I'm going to wait for you to catch up. I'm going to divide both sides by sine 7. Keep parentheses around that. So to find x, it's going to be 5,000 divided by the sine of 7 degrees, which is 5,000 divided by the sine of 7. Let's figure out what that is. So I'm going to put 7 and sine. That's 0.0121, and there's a 6 there, so I'm going to round that up, 9, 1219. So now I go 5,000 divided by 0.1219, 5,000 divided by 0.1219, and we get 41,017.2 meters. 41,017.2 meters. Let's try another one. We're going to finger track and read, highlight and underline at the same time. Tom is standing 400 feet away from a tree. 400 feet away from a tree. He uses a clinometer to measure the angle of elevation from his eye level to the top of the tree to be 38 degrees. Tom is 5 feet 4 inches tall, and his eye level is 5 feet above the ground. How tall is the tree? Now, what on earth is a clinometer? A clinometer is an instrument used to find angles of elevation and depression. Now we have finger tracked and read. We're going to highlight, underline, which we did. Draw, label, list. Let's try to translate this into a drawing. Tom is standing 400 feet away from a tree. So we're working with ground here. So I'm going to go like this for the ground. And then we have a tree. And Tom is standing 400 feet away from the tree. So here's Tom. And he's standing 400 feet away from the tree. That's the horizontal distance from here to here. That's 400 feet. He uses a clinometer, finds the angle of elevation from his eye level to the top of the tree to be 38 degrees. Now, why do I need to worry about eye level? Because he's holding this kilometer right at his eye level. So there's an imaginary line at his eye level right here. And at eye level, it's 5 feet off the ground. And to the top of the tree, that angle to the top of the tree is 38 degrees. We want to find the height of the tree. This actually is in 2 steps because finding this x is not the full height of the tree because we are short this 5 feet. But we are going to find x first. So we start by labeling opposite, adjacent, and hypo. And in this case, this would be our adjacent in this triangle. This would be our opposite, and this would be our hypo. And our adjacent here is not 400, excuse me, 500 feet. 400 feet. So, have, need, do. Have. I have the adjacent side. I need, in this case, the opposite. So I have an OA combination. What goes with OA? So, ka, toa. Toa. So what do? I write down my ratio. Tangent of theta over 1 equals opposite over adjacent. I'm going to stop, wait for you to catch up. So it's tangent, 38 degrees, put parentheses around that, over 1, equals opposite, which we don't know, we'll call it x, over adjacent, which is 400. We're going to cross multiply. So to find x, it's going to be 400 times the tangent of 38 degrees. All right, so we're going to find the tangent of 38 degrees here. So we do 38 tangent. We get 0.7813. 0.7813 times 400. That's going to be equaling our x, which is our opposite. So I take that and times by 400, and I get 312.5. So that means from here to here, I have 312.5 feet. Now that's not the true height of the tree, because that measurement was taken 5 feet off the ground. So to get the true height of the tree, we have to do 312.5 plus the 5 feet. And therefore it's 317.5 feet is the actual height of the tree. All right, page 41. I'd like you to try to do this one completely on your own. Finger track, read, highlight, underline, draw label list, Then do have, need, do. I'm going to give you a 3-minute time limit. Go. Okay, let's see how you did here. It says a research vessel using sonar to find an unknown object on the seafloor 1,000 feet diagonal distance from the hull of the ship. It's an unknown object, 1,000 feet diagonal distance from the hull of the ship. The angle of depression from the hull of the ship to the mystery object is 27 degrees. How deep is the object? Okay, so let's draw. We have ocean, and then we have the ocean floor. We have a research vessel of some sort. Forgive my unimaginative diagrams. We're using sonar, and the sonar bounces off a mystery object. Here's mystery object. That is 1,000 feet diagonal distance from the hull. So that's 1,000 feet. The angle of depression from the hull of the ship to the mystery object is 27 degrees. Depression is horizontal going down. It's 27 degrees. Find the depth of the object. So depth is a straight down concept. So there's your right angle and there's your x. Have, need, do. Have, need, do. Okay, we have, if this is our angle, this is our right angle, we have the hypo, which is 1,000. This is our hypo. We need the opposite. It's opposite of the 27 degrees. So we look at the OH combination in SOHCAHTOA, and what goes with OH is sine. So we're going to do sine of theta over 1 equals opposite over hypo. That's your sine ratio. So now we circle plug chug. We are going to do sine of 27 degrees over 1 equals opposite, which is x, over our hypo, which is 1,000 feet. Cross multiply. We have sine of 27 degrees, keep parentheses around that, times 1,000, equals basically x. So for this one, first we find sine of 27, so 27 sine is 0.4539 or 40, depending where you round. We're going to times that by 1,000, and we get 453.99, so it's 454 feet. So the object is 454 feet below the surface of the ocean. Check your work. See if you did it correctly. If so, fabulous job.